Hi everyone, in this video I'm going to show you how to drop an image into Desmos. The first thing that you want to do is go to desmos.com, and then if you don't already have an account, click sign up and go through the prompts. You'll want to create an account in order to save your work later. I already have an account, so I'm just going to click login. Now that I'm logged in, I'll click graphing calculator. And from here, we want to have an image to drop into Desmos. So I'm just going to open up Google. And since this is a parabola project, I'll just type in rainbow since I know that a rainbow forms a parabola. Now I'll go to images and I'll search for a rainbow that would be good. This one looks good because I could clearly see both sides of the rainbow. Down here, this image, for example, would not be good because you can't really see the left side of the rainbow. So then we wouldn't be able to identify the intercepts. So I'm going to choose this image here. So I will go ahead and take a screenshot of this image. Now, every device is different. On my device, I need to use the snipping tool in order to take a screenshot of the image. So I'm going to take a screenshot and then I'll save mine to the desktop because I just think it's fastest to drag and drop from your desktop. Now I'll go back to Desmos and I'm going to minimize my screen, and on the left here we see that the image was saved to the desktop, so I'll just drag and drop that right over on the left side of Desmos. So now my image is loaded. I'm going to change the title of this so that I can go back to it later. So on the upper left side where it says untitled graph, I'm going to call this rainbow parabola and save it. Now, if I ever want to go back to this graph at a later time, I would just click Open Graph on the upper left side, and then the rainbow parabola will appear there. The next thing we want to do is move the parabola around and adjust the size if necessary. Mine is already pretty conveniently located, but I'll give you a few examples. To move this image around, you would click on the image and then click the center, and you can drag it around the different quadrants in Desmos. Now, for this image, I don't want to drop it in the third or fourth quadrants because then I wouldn't be able to identify the x-intercepts. However, if your parabola opens upwards, if it has a minimum and it opens upwards, you would definitely want to put it in the third or fourth quadrant so then you could identify the x-intercepts. But for mine, I want to either put it in the second quadrant, the first quadrant, or in some combination of the first and second quadrants. To make my life easier, I'm just going to drop it in the first quadrant here. Now, another thing is that when you drop the image, you don't want to put it up high because then you can't see where the x-intercepts are. You want to drop it so that the parabola will pass through the x-axis. So now my image is conveniently placed, but I want to zoom in on the image. There's different ways to do this, and the first way is to click on the graph in Desmos, the white part outside the image, and then just drag the graph so that your image is in the center. So the next thing that we'll do is click this plus sign where it says zoom in, and we'll zoom in on the image a little. From here, I want to be able to see both of my axes. I can only see the x-axis. I cannot see the y-axis on the left. So I'm just going to, again, adjust this graph so that my y-axis is appearing on the left. So we still have some more adjusting to do because I can't see my other x-intercept. So instead of adjusting the graph by dragging it, I'm going to go to graph settings on the upper right side. And where it says x-axis and y-axis, I can change the parameters of the graph. So the x-axis is starting at negative 0.19, and I want it to go all the way up to, I'll adjust it to 10, and then I'll see if I can identify my intercepts. I still can't see my, my rightmost intercept, so I'm going to go to 11. And now when I go back to the graph, I can see both intercepts. And if I wanted to, I could zoom in a little more. So for the y-axis, the parameters, the y-axis is going from negative 2.19 all the way up to positive 3.9. So I'm going to change that. I'm going to change it to negative 1.5, and I'm going to have it go up to 4. And I'll go back here. So now I can clearly see my x-intercepts. Here's my first one, my other x-intercept, and it's pretty zoomed in, so I'm happy with the way this image looks. Another thing that you might have to do is resize your image. To resize the image, you would click on the image, and then you would hover over either a corner, a side, or the top of your image, and then you could change the size that way. If I change the top of my image, it kind of just, it condenses it, so be aware of that. It could completely change your graph. But I prefer to resize it through by using the corners. So if I were to resize this, I could just do it that way. Now that we have our parabola where we want it to, the next thing we want to do is identify our x-intercepts and any other point on the parabola. So on the left side, my leftmost x-intercept looks like it's almost exactly on the point 10. So I'm going to label this x-intercept 10. And when you do this, it's not going to be perfect. You have to estimate a little bit. And then my x-intercept on the right looks like it's right about there. And I'm going to estimate that point. It looks like it's about 10.2. It's going to be the point 10.20. So the last thing we want to do is identify any other point on this parabola. So it could be any other point on this rainbow here. I'll just give you a few examples. Suppose I wanted to pick this point right here. And again, there definitely is some estimating involved. I would estimate this to be the point 2. And it looks like it's about 1.2 for the y-coordinate. Now I'll give you an example of another point that would fall on the parabola. This looks like a good one right here. I can estimate that pretty easily. That looks like it's just about at 5 on the x-coordinate, and then 2.4 as the y-coordinate. Again, when you're identifying these points, there is some estimation involved. Now you know how to drop an image into Desmos, relocate it into any of the quadrants, resize it if you'd like to, and also how to identify the x-intercepts of a parabola in Desmos and any other point that falls on that parabola.